In this presentation today we'll see what is spherical aberration and what is the role of pupil in the eye to provide us something like a continuous range of vision so that we can see far distant objects as well as near objects, and how this optical is very spherical aberration is being taken advantage of to provide us with a continuous range of vision. So starting with very basic, it is known fact that the crystalline lens is negative as spherical aberration and the cornea has positive spherical aberration, and they tend to cancel out each other so that we are left with a very minimal amount of spherical aberration. Now before embarking on how can this be minimized in our intraocular lenses which are implanted after cataract surgery, we should understand what is spherical aberration. So this is a cross section, a very simplified representation of the eye, in a sense that we have the iris tissue, which is a semi-dilated pupil right now, which is normally our pupil in ambient light, and then we have the crystalline lens or a lens which is positioned just behind the iris. This is actually a very simplified and a basic diagram to understand what is spherical aberration. So when there's an object which is from infinity, the rays are coming to us and they strike the lens and they get focused. And the problem is the spherical aberration is that the periphery of the lens is far more powerful in the sense that it can bend the lights more than the central part, and as a result we have an image which is having a halo around it which consists of defocused rays which are not focusing on the screen. So if we keep the screen here, these rays are not focused. If we keep the screen here, these rays are not focused. As a result, we have a slight blur of the image, and this is normally present in a spherical lens which is known as positive spherical aberration. So what can be done is now we can improve the situation by enhancing this lens, in a sense that we make it the central part more curved so that it can provide us with more converging power, and as a result now the rays from the periphery and the center all are converging at a single point. As a result we have an object and a sharp image. So this is what we will have, and this will also mean that only particular distance, that is infinity, will be focused well, and any other distance will not be focused, so because all the rays are getting focused at one point. So what you lose is the depth of focus. Depth of focus is the range where which the object can be placed within that range and still the object image is partially or focused on the retina or screen. So this is one loss when you have zero spherical aberration. What if we make the central part even more curved? In that scenario, what is going to happen is the central rays are going to focus nearer and the peripheral rays are going to focus far away. And again in this situation there will be some element of the light energy which is traveling at different point of lens getting focused either front or at back, and as a result we have a situation where the image is now again like a central image with a halo around it. And this is true for any particular given distance from the retina, or if we move this retina here or here. But the advantage is there are few rays which are always focused within this given distance. So we have better depth of focus. And this is a lens which we can call negative spherical aberration. And this is how the eye would behave if a negative spherical aberration IOL is implanted inside the eye. So the iris, which is far away right now because it is semi-dilated as for the pupil size in ambient light, and we have some loss of contrast here. However, when the light is the same amount of light, but now the pupil is constricted because the person is trying to read from a near distance object where the rays are more divergent, and the periphery part of the lens is being covered by the iris tissue. As we all know, during accommodation, there's some amount of meiosis. As a result, the peripheral rays which are not focused are now cut off, and only the central part, which is having more power, more bending power, or more converging power, is exposed to the incoming light, and it is getting focused on the retina. So it improves the near vision, it cuts off the peripheral rays, so we have some enhanced contrast as well. As a result, we have a image which is better focused and also can show us near objects clearly. So this is the position of the iris and the intraocular lens with negative spherical aberration, and when the eye is attempting to focus near objects. So here we are with a design of lens which has a central bump, and these are IOLs with negative spherical aberration, and they can provide us a continuous range of vision. And this is one IOL from one of the companies which I am using, and I have discovered that it works wonderfully well for these patients, and provided that there is minimal amount of astigmatism, these patients have a commendable near distance vision, and which can get them rid of glasses for near and distance both. Thank you.